Welcome to Complex Systems Podcast. We've got the Multiverse crew here. And so we're talking about complex systems like we do every day. We had a discussion this morning about, different levels of complexity. And I think what we're going to really discuss today is the formal modeling of maps, right? We've made a whole bunch of maps through various different classes that we've done here. And so we're going to discuss those maps, talk about some of the definitions that are in the chapter 3 of the Complex Adaptive Systems book. That's going to be the Complex Adaptive Systems, Computational Models for Social Systems. Chapter 3 is what we're discussing today. I wanted to kick us off with a couple of definitions. If anybody's got a really good definition for a function, and we're talking about modeling, so rather than, you can draw parallels to programming and that kind of stuff, but just for our listeners, what is a function? Who wants to define?
A method of change.
Method of change, yeah, that's great.
That's basically defined.
Yeah.
In modeling, it's just to represent what's happening inside of a certain system at a given time.
It's method of change, way of changing something. In Python, a lot of times what we do is we pass in some values into a function, we do something to them, and we let them out the other side, and that's what a function does. So if you've done programming, functions. What about homomorphic? Anybody got a good definition for a homomorphic?
So I never ended up 100% getting the concept down, but from what I understand, looking at it from the input-output of the function, there could be several things that make up either the input or the output, and things can change inside of them that still make the end result the same in terms of value.
Yeah, exactly. If the function's outputs match based off their inputs, then we have a homomorphic function, even if they take a different route to get there, right? As long as the outputs are the same, functions are homomorphic. All functions that output the number 1, no matter what you put in, are homomorphic, right? Even if they do a complicated dance in the middle to ultimately arrive at 1. What about... So there was a term in there where we talk about equivalence classes. And it's that's a weird, set of phrases, especially if you haven't done software engineering. Is there anybody that can explain equivalence classes to somebody maybe who isn't a software engineer?
So I am not super solid on this, but with equivalence classes, it's basically it's a lower res interpretation of whatever your original state is. So if you take all of the important, bullet point parts of what you're trying to describe, but you can still describe that thing in a whole by using smaller elements, that would be considered an equivalence class.
Yeah, exactly. So we talk a lot about complicated systems and what you could represent everything in a system. You could model every single molecule, and I think the example in the book says something about weather modeling. We could model every single air molecule. I mean, we would really understand what the weather was doing, right? But that's not very helpful because it will take as much power as it takes to run the air. It's a lot, right? So we have to kind of reduce the model down to something like chunks of air or, some other ways of describing the fluid dynamics of gas, right? And so we end up with formulas, and the formulas that we build are equivalence classes to the real world, right? Or we're trying to get them to be. And so if they're homomorphic, then they if the basically the measures that we pick and the way that they transition are homomorphic, as in they're the same. The function, the model is the same as the real world. Then we've picked some good equivalence classes, and we've found them, and so we have to kind of find those things. Yeah, Sarah, what were you gonna say? Yeah.
So I was just trying to figure out a way to like explain. Um, from what I understood in the book, the example, it didn't really give a specific example for the charts that it gave, but according to those diagrams, so on top there were the real world, I don't know if you would call them models, but depictions, little circles. And then on the bottom of the diagrams, there were smaller, basically modeled versions of that. So you're trying to get from the top diagram into a modeled version of that. In the top, there were a bunch of different data points in each of the real world circles. And then you could see the modeled version had kind of abstracted or kind of like made like taken like all of those bunch of little data points and made them into bigger chunks to I guess abstract away like all of the little details, but kind of get like more of a just general understanding of what's going on. So then so that would be the equivalence. You're I think that's what it was. You're making an equivalence class based on the little details to basically the class. I mean, in programming, a class is a bunch of details that you want to abstract away into one like group. So you can use that group as one. So in terms of just like the real world, we're calling, I guess that's why you call it a class, but yeah, that's what the equivalence is. It's not like a perfect like model because you're not talking about every little detail, but you're basically breaking a bunch of little details into larger chunks to be able to understand like the general behavior of what's going on in the world. And then, the other term was the moving.
The moving?
The transitioning.
The transition, yeah. The function that we actually meant.
Oh yeah. So the function would be like you want to get so to see homomorphism, you would want your model's equivalence class like on the other side of the function to match like what the real world data is.
Right, exactly. And so we see the concept of equivalence classes in business actually a lot. The term for equivalence class in business is KPI, right? The thing that we're measuring, the little, and a KPI is not just the number that is in the spreadsheet column, right? It represents an element of the system, and the transition that it's making over time, right? So if we're going to build models, complicated models in business, in computer science, we have to we're trying to figure out what the function is, right? That's our goal as a modeler. We need to figure out how to make a function that's going to give us a homomorphic model, or at least as close as we can get, that has some predictive power over what's going to happen. Because the real world's, it's uncertain. Things change. We don't account for all the details. Sometimes it turns out one of those things actually mattered and we didn't get a good model. We don't have a homomorphic model, but we thought we did because it held true for a while, right? And this is a classical problem in finance, right? There's a lot of people spending a lot of money trying to predict what will happen to the price of any given stock at any given time, right? A lot of people are trying to figure it out. There's a lot of money in figuring that out. So there's a lot of incentive to do homomorphic modeling in the real world, right? The better we can model, the better we can use some of the systems in the world to our advantage, right? If I know about a system, I'm going to try to get free work out of the system, And so there's an element of feedback in that. As agents model the system better, what happens to the system? What do you think those effects would be? Let's say in the stock market. Let's just make some guesses. If we could do perfect homomorphic modeling of the stock market, what would immediately happen to the stock market? Yeah, Matthew.
From my understanding of why you're saying that the stock market is so hard to model is because of the fact that each agent is modeling the system and modeling other agents. So you would get to a homomorphic system, and then it would probably degrade because everyone's doing it.
Immediately, yeah. Because as soon as you have a homomorphic model of the system that doesn't take into account the agent's modeling of the system, you lose the modeling homomorphism, right? So models are good maps for small things, but once we get into larger and larger systems, simple equations are not cutting it, right? They're not working out as, just like we can say, f of s, right? The function that maps over the state. But we're hiding arbitrary levels of complexity there. That function could have anything in it. That function is the function that runs the universe, right? Like, that's ultimately the function we're trying to find a homomorphism to. And it's a pretty complicated system, the universe, reducing it is difficult. And getting any kind of accurate result out, it's really about how far out are you trying to model. So there's a problem in complex interacting systems that we've run into with the swamp ecosystem. And so some of us have been doing a modeling of an ecosystem where we're trying to figure out population dynamics, right? And as a population's growth rate rises to a certain degree, we start to get, it's sort of impossible to have a growth rate that will predict a non-crash to the population, right? Over time, the growth rates of different animals and their carrying capacities will tend to crash the population in our simple spreadsheet because our functions are not homomorphic, right? They're isomorphic. They're different in the way that, I think, isomorphic's different, or I forget. Sorry. But anyway, so we're running into this problem in our junior developer modeling of an ecosystem course, because we start to get into a level of complexity that becomes once we're dealing with populations, just a simple number is not actually how population dynamics work, right? But once we get into an agent simulation, and this is sort of shown in the book, we've got in the very beginning of the book, we talk about the audience, right? And trying to figure out, are we going to have a standing ovation or not? Are we going to have a cascade or not is the question, right? And it gets into the bees, right? The bees will cascade or not cascade based on their, based on what the dynamic is you're trying to model. If it's threat, you want a cascade, but not at a certain threshold. If it's heat, you want a slow cascade across many different thresholds, right? For stability purposes, And so the audience model in the very beginning, we just have a number. We just have people in the audience, right? And then we add okay, there's individuals in the audience, and if a certain number of individuals will, then other individuals will, and we see the cascade appear basically as soon as we have individual agents, right? So we're seeing this problem. So what are the key differences here? What is it in our spreadsheets that we can't capture, that we can capture in an agent simulation?
Things like at least for the clicker game, like growth rate and consumption, you could assign them like solid numerical values that seem reasonable for whichever population is at hand, but you wouldn't be able to assess like individual behaviors of like each like creature in the species.
Exactly, right. The individual behaviors, right? And so what is anybody know the word for that we've been using?
Heterogeneous.
Yes. Yeah. So heterogeneity as a key element of the system cannot be captured in simple equations, right? Where we say, this many agents do that thing, right? We can't really model it that way. We have to do it over time steps, right? And so we have to kind of take our simulation out of the spreadsheet land, unless we're going to use a column for every agent or something like that. And then we have to take it across multiple steps and show the transition for each agent at each step. So, how is it that we've been handling time? Can anybody give me an overview based on, playing with these spreadsheets in our modeling class when we're, or in our game development project? How have we been showing time?
Right now in the spreadsheet, it's just been steps. We haven't been giving it specific units because from my understanding, the purpose is to understand the relationships between the columns and the agents together. So it's just been 1, 2, 3 numerical, and all of the agents, usually parts of the system will tick up in relation to time, and then other parts of the system will feed back based off of those, or more based off time's relationships to an agent, and then the agent's relationships to how each of the agents grow.
Yeah, exactly. So there's a lot of basically there's elements that we've stacked on top of each other, right? We've got time kind of, as rows down the page, and then we've got agents, populations as formulas on different columns, right? And so if you think back, we're kind of at the audience level of modeling our ecosystem here, where all of the agents are stacked on top of each other, right? We don't have the notion of, there being an actual physical space and people being able to see one another, right? And so in order to figure out will there be a standing ovation or not, we had to pull all of the agents and give them, positions in space and time, right? We had to give them coordinates, and we had to give them individual states, right? A threshold at which they would stand that was different. And that's one of the key things. It's the same idea with the bees, right? If you have some people in the audience who will stand because they have a low threshold for quality of performance, and then everyone stands over time because the audience is has heterogeneity, there we go, in their threshold. We cannot model that very simply by just, without things like computational modeling, right? And this book, I think Complex Adaptive Systems was written long before people were routinely writing a whole lot of really, really complicated video games with hundreds and thousands of units in them. Some of the more complicated games like actually do have thousands of units, or at least hundreds of units with tens of properties. And so we end up with, thousands of interacting variables every second, right? If you think about some games, what are some games that y'all can think of, just if you've played any, that have unit dynamics like that, that where we're seeing a complex adaptive system that must use agents, that couldn't really be reduced to rows in a spreadsheet? Sims, yeah. Yeah, Sims is great for that. Yeah, we've got individual agents. They interact. They have relationships with other agents. That is the most complex adaptive social system modeling game that there is.
Also, Matthew's game.
Oh yeah, Matthew's game is like that too. There's individual agents wandering around, ducks that follow their mom, etc.
Yeah, it's like open world sandbox games like Grand Theft Auto or Red Dead Redemption, where they're like a ton of like NPCs or whatnot, but they have like dialogue and they also respond in a different way depending on your status, like notoriety or like how you're perceived in the community.
So, this is the key distinction that I wanted to bring out. Just because there are agents doesn't mean that we've modeled a complex adaptive social system, right? We have the concept down, the concept of reputation and factions. And so we've created a play wherein you make different state changes to those elements. But the elements in, for example, Grand Theft Auto 4, right? The factions don't evolve without your input, right? You have to manually take actions in the story which will cause these factions to grow in power or these factions to grow in power. I don't remember if it's 4 or 5 or 6 or whatever. I haven't played one of these in a minute, but in most RPGs, the factions don't evolve without you. In a massive online RPG, the factions evolve without you, but it's not the simulation that's driving the evolution. It influences the evolution, but it's fully a social system that has a simulation that influences it. But we're seeing a complex adaptive system there, but it's a human-run social system. It's a model that we might, or it's not a model, it's something we might want to model. There's a lot of people who model EVE Online, and it's like profound economy that's really realistic. That's because it's a real economy, because real people are exchanging real money for goods and services. Like, that's just an economy, It's not a simulation of an economy. And this is really, actually, it's a fine distinction to make, because realizing, like, if you look at Dwarf Fortress is a complex adaptive system. It's not exactly an RPG, but there is an RPG mode that is a complex adaptive system, because the factions evolve according to rules that are part of the simulation. And so you don't have to get involved to make something happen. And so it's not really a script or on rails. It's an evolving world. Sarah, what were you going to say?
Would you consider Neopets a complex adaptive system?
Again, it's difficult. I mean, so like
there were economies and trading and buying.
Those were real economies, though, right? Like, just because the items that were in the economy were not not real, it doesn't make it a not real economy. It's just an economy of virtual goods. If people will value those virtual goods and will exchange currency that is not in-game for them, then it's a real economy. And if they value those goods enough to do things in game to get them, it's still a real economy if there's player-to-player exchange. If there's only player-to-system exchange, but the system doesn't evolve without you, it's not a real economy or a simulation of an economy. It's just like the shopkeeper in a video game. Like, the thing about video game economies, they're very easy to break because you can go out into the woods and find like the monster that becomes diamonds, right? And you go to the shopkeeper and you sell the diamonds, and the shopkeeper always has the money to buy the diamonds. And it doesn't bankrupt the town for the shopkeeper to buy the diamonds from you. And, things like that, right? Like, the shopkeeper never has to like mortgage their house. If the diamonds get stolen, the shopkeeper doesn't there's no insurance in the game like that right. Like, there's no interaction between the economy and the value of goods and services and anything that you do. It's just like, I went and got some pelts. There's infinite pelts in the forest and the shopkeeper has infinite money. So that's just a game. Like, but it's not actually an economy just because there's buying and selling, right? But in Eve, we have a real human economy, and it's not a simulated economy at all. The frequency of resources is controlled, and so it's a manipulated economy. But the money corresponds to real like human labor most of the time. Matthew, what were you gonna say?
Something like Rain Worlds, would that fit in the same category as, or something else?
I have been reading about that there is an ecosystem in Rain World that's very detailed, but I don't know how much of it's simulated without you there, if that makes sense. Like if moss grows or like plants grow back, but then creatures come by and eat those plants sometimes, and if those creatures can't find those plants, then the creatures may die. And if those creatures die, then you can come upon their corpses. Like, that is a like complex adaptive system, and then if their corpses are like consumed by another creature that then gains longer life, like doesn't starve because of that, like, that's a complex adaptive system because there's an adaptation layer, right? Something can be complex but not adaptive. Something can be adaptive but not complex. And something can be complex and adaptive, but not be a simulation and instead be a complex adaptive social system, right? A Discord server is a complex adaptive social system, but it's not a simulation. Like, it's people in the Discord server, A social media site, is a complex adaptive system, but it's not a simulation, right? Because there's no fake players. There's no like artificially limited number of coins that like spawn. I'd say the Neopets economy had some, like, it was a controlled economy. Things like the food would only be in the shop for so long and you had to get a certain amount of it, and there was like a reason to get it. You had to do it to play this game, and so it was like, and then people would...
That created scarcity.
Yeah, real.
And then people had them, and then they could sell them to other people.
Right, exactly. And then so there was like price fixing and manipulation. So there was like supply and demand curves that changed the system. Then it's real, but it's real and not simulated, right? So if we want to predict the price of Neopets food, it's actually pretty simple because there's not that many other things you could do or get, really, because there was like one variable that mattered, which was, is your pet fed? And so you could have 4, and there were like so many people on the platform, and you could know how many people there were on the platform that were active. I think there was like a certain number. It was like a number, right? You could see it. So you could figure out, okay, if there's this many people active and there's this much food available for this many Neopets, then there's this much demand for food. And if there's less food than demand, then there will be a rise in prices, right? Or, yeah, it'll be manipulated, And you could predict that the price of food would rise over time as people saw that that was a thing. And so you could see that people's modeling of the system created feedback loops. So there was like a thing, I remember this from when I was a kid, there was like a crisis because you couldn't get the food, right? There was a famine. And it's, it's just like food in the little store. There's only this many that spawn. And if you don't get one, then you didn't get any food, And it's like your pet wouldn't die, but it would just be like starving and angry at you,
I thought they allowed for pet death, at least when I was a kid. Maybe they added that in later.
Allow for that. No, I don't know.
I remember, like, if you went back, like, people would, like, when I was a kid, people would play, and then I remember, like, 10 years later, people going back to their Neopets, and you could still log in.
Yeah.
And then, oh, your pet's dead.
Oh,
get a new one.
Oh, wow. Yeah, no, I didn't know. Yeah, they must need to clear out some database rows somewhere, No, I didn't know that happened. But yeah, I mean, so, a famine's more serious in Neopets than it used to be. But like there was a problem. They just weren't spawning enough food for the player base that was in existence. And then that caused price gouging. So like when there's a crazy demand curve that just goes insane and the supply can't even slightly do it, then there's suddenly the difference between the demand and the supply is the amount of capturable energy based on how critical the good is, along some coefficient, right? And so, yeah, price gouging on Neopets food was an early introduction to economics that I got personally. Yeah, it's interesting. These models, video game engineers, we give them a lot of flack a lot of the time for like not balancing the economy properly. It's hard to do because people are trying to unbalance it in their favor at all times, right? If they can figure out a way to predict the system, then they will try to get free work out of the system. So how is it that we get to robustness then? Like, how is it that these economies, if they're so fragile, don't crash? Why is it that EVE Online is still a multi-million-dollar economy? Maybe almost, I don't know how big it is, but it's a multi-million-dollar economy inside of a game. Why?
Simple economic principles, supply and demand, scarcity of supplies. People usually, in games like that, in MMORPG, people will usually have to mine. There are usually drop rates are low for certain things that are usually of value. So, in a way, it's like its own ecosystem that functions on its own. And as far as like developers, I don't know how much control they have over like the player-based behavior.
Right.
Because at that point, the players are playing for their own self-interest. Mm-hmm. And it's always about undercutting, buying low, trying to clear out space. Sometimes people will actually play the auction house to see if they can get more money out of it, try to control one item, like supply line. I've tried that in the past with World of Warcraft. So like I've seen these, like I've had to deal with some of these things. And then there's also like add-ons that people have now that can do the math for them, tell them what the value of certain things are. Mm-hmm. So
there's another element of feedback directly into the system, right?
Yeah.
Yeah.
On top of that, you also have the stuff that you can actually manufacture. So and then sell them there, which also requires materials to buy or go look for that can be rare. Yeah. So yeah, the economy is it's a really weird economy.
Yeah, it's similar, it's it's a real economy though, right? Like, so when they model this economy and they're trying to figure out like, what's going to happen to the price of pixie dust or whatever, it's the literal same exact process as trying to figure out what is the price of yams going to be next year, like, or like pig or wood, right? Like, we didn't have any prediction over the price of wood. That when there was a pandemic, we would get crazy prices for wood, or that the price of houses would go insane during the pandemic, right? Like, we had no prediction for that, because why would that happen, and how would you have predicted that, But also, we can look at historical precedent and see what happened to the prices of certain things during stuff like that, but we didn't have a protocol the last time there was a grand, 100-year, pandemic, right? We had no okay, everyone stay in your homes and don't go to work. We've never done that before in the history of ever, right? So there was no way to predict that would happen based on previous events, and there's no way to predict how the next one will go, because we don't know how world governments will respond to it, right? Based on the previous one. So, there's a lot of feedback elements there. So if we can't predict how an economy will go, how come they don't crash? Why is it that the World of Warcraft economy is still going? Why is Eve still going? Not just scarcity, right? But what are some of the dynamics, the names of the dynamics that cause it to be robust against the unavailability of a random thing or something, or the overabundance of something?
Well, as much as we want to say that it's an independent ecosystem, there are people who are looking at it and caring for it. So if they see that something is going to make the whole thing crash, they probably might have an influx of a needed resource.
Right.
In the real world, that actually is a thing. When a bank is about to go bankrupt and millions and millions of people are going to be affected, the government might add an influx of money to save them.
Yeah, exactly. Yeah, there's the agents themselves are a big element of distributed control in the system. While there's the concept of a bank run where people will just, oh no, the bank's going under, we're going to lose all our money, we got to go get as much of it as we can now. And that's what makes sense to do, right? If your bank's collapsing, go get your money, I would never give the advice to people well, if the bank's collapsing, just let it collapse. And, that's how you stop it from collapsing, is just don't act like other people and with fear. That's terrible advice for the individual. And so, yeah, the thing is, if the bank is being run on, what happens? The bank professional, or the CEO of the bank doesn't continue to play golf, and people don't just kind of come into work and go, oh, the bank's crashing, I don't know, hope it doesn't. They don't, they work there, they're doing stuff, there's somebody in charge of making sure that doesn't happen, right? Are they always able to succeed? No, but the number of agents that will pull to maintain the value of their current investment the number of them that shows up usually creates robustness in the system, right? If there's a question a lot of people say about predators, right, in ecosystems. When you start modeling ecosystems with incremental gains, you run into the predators, right? The predators don't die because nobody kills them. And so they become these super long-lived things, and then they overpopulate and they crash the prey population and then die, right? And so if you're just modeling it with numbers, you're not going to see what really happens, which is that the predators fight each other because they don't want there to be too many predators. And so then they become like hostile to their own species and then thin out their own herds, right? So that the carrying capacity is a thing. And they don't always have too many babies when they're like, they're not just, oh, there's all this space and it can accommodate 1 million of me. I'll just have 1 trillion baby. Like, they actually don't do that, like cats and stuff, if they feel like there's too much, too many other cats around, they won't try to have, kittens. And, like, will they always succeed in not having kittens? No, but like they will try, they will hide, they will not actually, engage. So it's a thing that we see in predator dynamics as well. So it's not, you don't have to be a cunning planner or like, a world government that has perfect like execution capacity because people, and things want to preserve themselves, right? Like you said, there's people who are invested in EVE Online. They want their ships to continue to be cool ships, right? They want their EVE Online company to keep going so that they have a reason to hang out with their friends. And so they care and they're going to like argue with the developers. They're going to do the math on their own and go, hey, if you stop spawning iron ingots in this cluster, then it will cause all these chain reactions down in our thing. And then the developers are like, would that be an interesting thing for the game or not? And so then, depending on whether or not it's like, oh, you've had a stranglehold over this part of the galaxy for too long, let's stop spawning the iron ingots just to cause you some chaos. And then they're like, no, and it's like, it's a dialogue, it's a back and forth. So this is how game designers actually do that stuff. But they can't without feedback, right? Without a player conversation, without having forums, right? Can you imagine trying to make an ecosystem for your players and then having no forums that you could read about your players and how they were doing things? Would you know what you were doing or whether or not people liked anything? So yeah,
there were Neopet forums.
There were. That's how they got the info. Yeah, Matthew, what are you gonna say?
What would it be considered for? I think I read an article that a lot of these games also have underlying money laundering or other systems under side industries that are happening.
Mm-hmm.
What would that be an example? Would it be heterogeneity in systems where there's different systems in like adding stability, or what would that be?
Yeah, so that's going to probably be heterogeneity, and this gets into elements of the system that you have to model that you kind of forget about, right? Like, most companies don't put in their budgets in the first few years the amount of fraud that will probably happen, right? With their product. And so then eventually they have a line item fraud, and that kind of stuff. Or they get like chargebacks and things like that. If your medium of exchange is too readily, if your currency is too liquid, it becomes used as transactions for other systems, right? And this was a thing, World of Warcraft used to be a money laundering scheme because people would buy gold so readily that the mafia was like, great. So then the mafia started buying gold, and literally using it to do things because you could just convert it. And it was like you could buy a World of Warcraft character that someone else had leveled off the internet and then use these two characters to make the exchange. And boom, there's no record of your exchange, and you lose only a certain small amount for each like transactionary middleman, right? So, And then you could convert it into any other currency too. So you'd go from, United States dollars to World of Warcraft currency to like rubles, and you'd be good to go. So yeah, there's the thing about money and the thing about money and power is that it follows a path of least resistance. And so if your currency is very fluid, power will flow through it with less resistance than currency that is less fluid. So if you think of like, I don't know what they use in like Tuvalu, but like it's less fluid than the US dollar. And just because it's a small country, really tiny. And so like Tuvalu currency, it's hard to use it to do stuff like money laundering because are there a million free US dollars in Tuvalu currency out there in liquidity? Maybe not. It would be very easy for you to see that transaction if you're like, yeah, I'll just take all of the free available currency in your whole economy and use it to execute one transaction. That seems legitimate. No. What were you going to say, Ramsey?
I was going to say that those WoW gold farms that they had in China for World of Warcraft, it almost felt like it was like the birth of the crypto movement, and that's how crypto got started.
Oh yeah,
because there's so many parallels of how that was managed compared to how those were being managed.
Yeah, a lot of cryptocurrency, the new especially Ethereum and people who wanted to build off of cryptocurrency that wasn't Bitcoin. A lot of the design decision of using something like Ethereum was so that you had a trans game currency. So that, you could play your like Candy Crush and then turn it into WoW Gold and then take the WoW Gold and then actually I'm going to go play EVE Online with it, And that was the dream. That was what all the game devs wanted to do. Because, yeah, you play a game and you get cool swords and you get stuff and then you kind of don't have credit for it across all the things. And that was sort of before, I don't know, Xbox did achievements, really. And before they were really, nobody respected achievements at that point. And there were just like a ton of achievements that didn't make sense. But once they got to be a little bit more verified and like the points values started to mean something, that was when we really started to see an uptick in, using cryptocurrency for stuff like in-game currency. Because there are so many applications built on Ethereum, it's more fluid than many other cryptocurrencies. And I think if you've played the cryptocurrency game, you've seen this. It really takes a long time to sell a cryptocurrency that nobody wants. Why? Because no one's buying it. And you have to like literally wait for someone to want to buy it. And maybe it might be days before someone's like, yeah, I'll buy some cryptocurrency. And you might only sell 30% of it, right? And so like the exchanges wait until, your sell order, they like sell portions of it sometimes too. I'm sure you've seen this maybe, right? So there's a number of issues with these things, but these are real currencies, right? These are real economies because they're real people deciding that these things have value. In the same way that video game economies are exactly as real as cryptocurrency economies. It's just that some people value it as what gives it the value, right? Because they will exchange goods and or services and or real, regular, normal money for them. So that's what gives them the value. It's very.
I've heard a lot of people refer to the stock market as basically just one big game.
Yeah, and it is. It is. Next week, I think what we're going to discuss is finite and infinite games. So there's a book up in the curriculum for it for y'all to read, and the first chapter or the first 2 or 3 chapters, I think, will take you through it. I'll send out an email here in a little bit with the actual chapter assignments. And if you're seeing this on YouTube, you'll see the chapter assignments in the description. But yeah, we're actually going to talk a little bit about game theory, because the goal is not always maximize the number, right? Like, who here is trying to only maximize the number of dollars that they make in their lifetime? Who here is doing that exact thing? And that's their number one. Really? You'll sacrifice anything for it? Everything? Love? Your family? You don't care? Anyone? Everything? All right, it's just Rosie. The rest of us are like, okay, friends, so I like to go to things and like concerts and, exist and stare sometimes off into the distance doing nothing. So yeah, so like if you're optimizing for that one number, that's usually not the case. Most people are playing the game for the continued play. The purpose is to continue the play of the game. So EVE Online is an infinite game. World of Warcraft tries to be an infinite game, but you top out and they kind of keep having to add more content, right? But EVE Online there's not really a way to max out. You just build bigger organizations. So the game is in the people. So there's certain subject, or there's certain things that make a game infinite and certain things that don't. And so we'll be talking about that. Sarah, what were you gonna?
Is Dungeons and Dragons considered like infinite? I don't know if there's like an online version. I've never played, but from what I've heard about like the in-person versions, they just go on forever.
Yeah, it's an infinite game. The purpose is to continue play. Minecraft.
Would that be considered a complex adaptive system?
Not well. It depends on how the dungeon master arrives at the thing. It sort of is a meta system in that the players share a lot of details. It's an infinite game, but it's not necessarily a complex adaptive social system. Like the dungeon master can decide that some stuff happened, but there's not like a simulation where we can make a model and predict something that we would otherwise have to just wait and see what happened, right? There may be a model in that person's head. They may have like a dungeon, a dwarf fortress simulation that they've set up to be like, okay, and then the skeleton lord, so, there may be some, but like usually no. So, yeah, games are a great study for the real world. I mean, that's what we're doing when we design a game, is we're trying to make the real world, but more fun and less. We're trying to literally build a homomorphic system to the real world, but take out all the parts that we don't like, and we pick some key measures that are fun or at least interesting. And then we try to make a homomorphic function. So that's game design in a nutshell, but also the design of many things. So, models as maps. Thanks for coming. We'll talk about models as maps and emergence next week.